Okay. Hello. My name is Divyang Vaidya. This will be a presentation on the 104 Lab 3 for SJSU. Let me go ahead and share my screen. So for this first exercise for 104 Lab 3, we did a curve fit using polynomial regression. This first line of code, P is equal to NP dot poly1D 1 -8 9 -8. It creates the polynomial function, print P order. That prints the order for the polynomial. So this is a third degree. So we have x cubed minus 8x squared plus 9x minus 8. Print P, it just prints this line for the polynomial. X is equal to 9 np dot linspace negative 0.56100. It selects the scale for the x-axis for the curve fitting. Y is equal to px. That calculates the y values using the polynomial directly. So we're just basically assigning this and asking it to do the calculation. For the model is equal to np.polyfit xy3. This line fits, it's basically a line that's telling the model to, okay, we want to fit a third degree polynomial and assign it to the variable called model. And pfit is equal to np.poly1d, comma model. What we're doing is we're basically putting model as poly1d. YPRD is equal to pfit x. What we're saying here is we're utilizing the fitted p values, uh, uh, the fitted y values for the polynomial. Plt.plot x, y, b minus. That's just setting the plot for the b minus, which is basically the grid for the plot, setting that up. Plt.plot xyprd, that's g minus. This is basically saying, okay, that we want to set the scales for the grid and for the plot so it shows up on the console. Plt.show, this basically is just a single line that says, okay, just show the plot. Now let me run it. So this is the curve fit that we have chosen. And as you can see, this will match the Desmos. So let me open up Desmos, the Desmos graph that we've created based on this, which is right here. So as we can see, 1 minus 8, 9 minus 8. That's basically right here, 1 minus 8, 9 minus 8. Those are the coefficients for the polynomial. So this is the plot of the Desmos. Let me zoom out. As you can see, it's a curve fit for this. So this is a third degree polynomial. And over here, we assign it so it fits using the polynomial regression method. So that is it for this exercise 1. Now let's move on to exercise 2. Exercise 2 is using the curve fit using pipeline ridge or the pipeline linear regression method from lecture 4. So for this one, I've chosen to use the linear regression method. So linfit is equal to st.lingres xy. That's basically setting up the linear regression method and assigning it to the variable linfit. Ypred is equal to linfit.slope times I linfit.intercept for I and x. That sets the line through the xy values. Plt.plot, that just plots the original curve fit. Plt.plot ypred. Just like exercise 1, that line displays the intercept line, the intercept through the graph. Plt.show, that just displays the plot on the console. So you can basically run it. For the linear regression method, what it's doing is that it's basically making sure that a line fits perfectly across. That's using the linear regression method to do a fitting across that the polynomial that we have chosen. So let me run it again. So right here, that's the line that we've chosen and it fits directly across. That's using the linear regression method. And so now I'm going to move on to exercise 3. This is going to be the damped sine wave curve, which is from lecture 2. So for exercise 3, we have def damped sine. I'm basically assigning a function and I'm assigning an x in a, b, c, d. This is basically saying the first p is the sine multiplier. So in this case, I've chosen a. So a is the sine multiplier. The second is the phase. So the second p. which is basically B in this case. So B is the phase, the third P, which is the exponent weight, which is C, that is the exponent weight, and the fourth is the overall gain factor. So this corresponds to the formula. Let me pull it up from Desmos. So as we can see, this is the formula for the damped sine wave, and our chosen values were 3, 2, 4, 1. So when we go back here, we can see that the chosen values are 3, 2, 4, 1. And as usual, the fourth is the overall gain factor. We've got the third, which is the exponent weight. The second is the phase of the graph, and the first is the sine multiplier. So xv is equal to x over 10 for x in range 400. That creates the x values in that range of 400. And yv is equal to damp dot sine. So what I'm doing is I'm assigning yv as a variable for this function. So I'm taking this function and I'm feeding it to yv. And I'm assigning it, again, the coefficients here. So the coefficients are 3, 2, 4, 1 for the damped sine, which is this function. So I'm passing it on to here, which is going to match what we have here, 3, 2, 4, 1. So if we zoom out, this is the damped sine curve. And for the PLT plot, we're basically just showing the plot for the damped sine curve. So it's PLT plot XV, YV. So again, XV, we've assigned it for X over 10 for X in range. So this will divide it by 10 and we'll assign it within this range 400. So those are the X values. Y is the Y values for this function, damped sine, which we've again declared here. So POPT, P cove is equal to op dot curve fit, damped sine XV, YV. That is going to be the function that uses the nonlinear least squares fit to nonlinear least squares to fit data to the function. So what it does is basically, all right, I'm using a nonlinear least squares fit to make sure that that function fits the graph. That's essentially what it's doing. And it's doing a curve fit as well. So a curve fit of that function. So it's taking the values that we have here that is declared in XV and YV, and it's feeding it into the op.curve function. So plt.plot XV, YV, be label first. So I'm setting up the label for it, for the graph. plt.plot XV damp sine, XV POPT star. That's basically a pointer. And R minus label is equal to curve fit. So that is basically naming this plot the damp sine wave curve fit. So it's setting up the labels. So the grid, so the first line, the blue is the first, and then the red is the curve fit. It matches up perfectly, so it's kind of hard to see, but it's there. So plt.title damp sine wave curve fit, that just labels this top part of the graph. So let me run it again so you can see it. So that's going to be this graph. So it's kind of confusing, all this graphs here. So let me just close the console and I can relaunch it. Yeah, this is it. I know it's a little bit tough to see that we've got a blue one that's matching up, but it is there. It's the first and then the curve fit. So that takes care of exercise 3. And in the next video, I will be explaining exercise 5, which is the curve fit with multivariables from lecture 3. I'll see you guys then.